Have you ever seen The Matrix? Chances are that you have. It's a rather popular film. In one particular sequence, the protagonist Neo is presented with a conundrum. The red pill or the blue pill? A choice between learning the absolute truth behind reality and the blissful ignorance of illusion. Neo eventually decides to take the red pill and does indeed learn the truth, as horrifying as it may be. He learns that he's been living inside a simulation this whole time and he's now finally experiencing true reality. At least, that is what you, the viewer, is led to believe, but an aspect that is somewhat dismissed is that the red pill doesn't grant you knowledge of reality as much as it completely eradicates any distinction between real and fake. Let me ask you this, when watching the movie, did you ever question if the supposed true reality that Morpheus and the gang exist within is actually true reality? What's to say that they are not inside a simulation themselves? I mean, up until this point, the Matrix was just as real as this newfound reality. If anything, the Matrix only proves that knowing what reality is and is not is an impossibility. And this could potentially go on for infinity, never reaching any sort of true, actual reality, if that even exists. Just a simulation within a simulation within a simulation within a simulation within a simulation. Yeah, and so on and so on and so on. This video is not really about the Matrix per se, but it's hopefully a digestible introduction to the profound and intricate topic of this video. The idea that the universe and reality itself could be a simulation is not something new. We can trace similar ideas as far back as the time of ancient Greece, when numerous philosophers around the world alluded to the idea that reality could be an illusion. Chinese philosopher Zhang Zhu compared his own existence to that of a dream in which he believed himself to be a butterfly. He questioned the distinction between reality and a dream if both could seem equally real. Another example is Plato's allegory of the cave. The first part goes like this. Imagine a cave where people have been imprisoned since birth. They are chained in such a way that they are forced to constantly gaze upon the wall in front of them. They cannot look around the cave, at each other, nor at themselves. All they know is this wall and nothing else. Behind them there's a fire, and between the prisoners and the fire there's a walkway. When people walk between the fire and the prisoners, shadows are cast upon the wall. Because the prisoners doesn't know anything else, they believe the shadows to be real, actual entities of their own. And when a passerby is talking, the prisoners believe it to be coming from the shadows themselves. They have no idea that the shadows on the wall are merely lesser copies of reality and falsely assume that this partial reality that they can perceive is the complete truth. There are many interpretations of this allegory which can be applied to a vast range of topics. It can be interpreted as a way of understanding the importance of knowledge and how it shapes reality, or it could be an analogy for human ignorance and our unwillingness to seek truth and wisdom. It could also be read like this. Just like the shadows in this cave, could our perceived reality be a shadow of something else? In physics and cosmology, there's now a subfield called digital physics, which is a collection of theoretical perspectives based on the premise that the universe is describable by information and as such is computable. And some of these physicists around the world are actually trying to find out if our universe could be a simulation, commonly referred to as the simulation hypothesis. This is done by, in various ways, comparing the real world against our own technology. If certain similarities are found, conclusions can be drawn. One such study, titled Constraints on the Universe as a Numerical Simulation, concludes that it is possible. A really simple analogy is to think of the pixels on your screen that make up this video right now. When I move this red dot across the screen, we perceive it as a smooth, sliding action. But we know for a fact that this is an illusion caused by the limitations of our sight. nothing is really moving. It's just bits of information being modified in such a way that from our perspective, it's perceived as motion. If we zoom in and slow down, we notice that the red dot isn't sliding as much as it snaps to each individual pixel. And this is essentially what they have observed, that the universe has a finite resolution, or an underlying lattice, as they call it. This could mean that the universe and reality is not made out of energy or matter, but is instead made out of quantized bits of information that, from our perspective, is perceived as energy and matter. Another way to imagine a computational universe is using what's known as a cellular automaton. A cellular automaton consists of a grid of cells. In this case, each cell can either be populated or unpopulated. We then need to specify a set of instructions so that the state of each cell evolves over time based on the state of neighboring cells. It may sound complicated, but it really isn't. Let's start with something simple. For example, we could say that each unpopulated cell will become populated if a populated neighbor is found to the left. We then populate a single cell and execute the program. What happens is that for each increment of time, a new cell is populated to the right of every populated cell. So in this case, it just continues to the right forever. Not very interesting. Let's make it a bit more complicated by using the instructions of a popular cellular automaton known as the game of life. These are the rules. Number 1. Each populated cell with either one or no neighbors becomes unpopulated. Number 2. Each populated cell with 4 or more neighbors also becomes unpopulated. Number 3. Each populated cell with 2 or 3 neighbors remains populated. Number 4. Each unpopulated cell with 3 populated neighbors becomes populated. We populate as many cells as we'd like and then press play. The resulting behavior is actually quite remarkable. I mean, it's not GTA 5 or anything, but still. What's remarkable is that these 4 simple instructions can over time produce incredible complexity. Cells can live, die, or multiply and create a sea of seemingly chaotic randomness. Some configurations stop immediately, while others seem to continue forever, and there is no guaranteed way of telling if any specific configuration is eventually going to stop or continue indefinitely. If we zoom out as the model continues to expand, increasingly complex patterns begins to emerge. But not only patterns, over time even the behavior changes. The interactions between individual cells is overshadowed by the behavior between entire blocks of cells. And this is the idea, that the universe began as something incredibly simplistic, like a grid of cells governed by a few simple instructions. But given enough time, it evolved into something incredibly complex. It's only natural for us to assume that the complexity of the universe must be very complicated. The world can often seem very confusing, random, unpredictable, and even unexplainable. What the game of life quite elegantly illustrates is that complexity can actually be the result of simplicity. If you and I and everything around us is the result of computable information, it stands to reason that that information can be modified and manipulated to an endless extent. We would be nothing more than puppets in a theater. Maybe the simulation began seconds ago and we only think it's been 13.9 billion years because that information was artificially included upon its creation. Maybe the universe is really, really tiny and all distant celestial bodies are simplistic renditions to create the illusion of enormity. Maybe nothing physically exists until we observe its existence. Perhaps detail and complexity is added when it's needed instead of being constant and absolute. Perhaps discovering that this is all a simulation is part of the simulation. Perhaps this isn't the first iteration of the universe and someone could be pressing the off switch right now. Don't get me wrong, all of what I just said is absolutely insane. But that's kind of my point. If we accept the simulation hypothesis, we also accept that literally anything is possible and that nothing can be determined. Imagine that we somehow found definitive proof. So for the sake of argument, let's say we escaped the simulation. Then I think we could all agree that we would know that it's a simulation, right? But we still wouldn't know if our escape from the simulation was simulated in and of itself. In other words, we could still be inside the simulation. It's a so-called infinite regress issue, which means that any evidence we find or knowledge that we obtain could just as well be simulated in and of itself, including any evidence that it's not a simulation. As the extent of the illusion cannot be determined, nothing can be determined. In the first draft of this script, I addressed many radical ideas surrounding the simulation hypothesis, but as it can all be nullified by asking what if it's part of the simulation, it's really not that interesting. There's little, if any, scientific value here. It's mostly philosophical and metaphysical, and it's all very analogous to the limited reality of the prisoners in the cave. So let's change our perspective. Instead of assuming the position of the prisoners in the cave, could we be the ones who ignite the fire to cast shadows upon the wall? A big reason why ideas related to simulating reality has become so popular in mainstream media like movies and video games is that on the surface it seems very plausible. If we look at what we could do just a few decades ago and compare it to modern technology, it's easy to imagine a future wherein technology has advanced far enough that it's indistinguishable from reality itself. And while there's nothing that explicitly prevents that from happening in the future, there are definitely limitations to what we can and cannot do. Over the past half-century, the processing power of computers has doubled every 2 years, which is an observation known as Moore's law. But this growth won't continue forever. In fact, it's already begun to slow down. It's now closer to 2.5 or even 3 years. The reason for this decline is due to the physical limits of computation. Computers are fantastical and can do incredible things, but they are not magical. The speed at which they process information and the amount of information they can process is, like everything else, governed by the laws of physics. For example, we will never, regardless of any potential futuristic technology, be able to accurately replicate anything down to every single molecule, atom, and fundamental particle. And the strange world of quantum mechanics is to blame. There are many reasons why quantum mechanics makes this impossible, but one great example is the uncertainty principle. It states that the more precisely the position of a particle is determined, the less precisely the momentum of that particle can be determined, and vice versa. You can think of this as a balancing board. We force the left side down to increase precision in measuring the position of the particle, but in doing so, the right side has to go up, and thus we lose precision in measuring the momentum of the particle. To be certain about both properties at the same time would require us to break the board, or in this case, break the laws of physics. The uncertain and probabilistic nature of the universe makes exact replication an impossibility. So let's forget about any notion of exact replication. It just isn't, dare I say, realistic. What we can do instead is mimic reality by approximation. Take a look at this. This is the Illustris project, a giant cosmological simulation with the aim of studying the formation and evolution of galaxies. It's an ongoing project in which scientists use the most precise data and calculations currently available to create the most precise model of the universe possible. At its highest resolution, it had a volume of 106.5 cubic megaparsecs, took several months to complete on a supercomputer with 8,192 cores, used 25 terabytes of RAM at its peak, and had a particle count of over 18 billion. Of course, it's only realistic to a certain extent and from a very narrow perspective. The simulation is detailed enough that they can actually zoom in on individual galaxies, but it's not detailed enough to simulate the birth of each individual star or planet, and certainly not the astronomical numbers of individual molecules and atoms and so on. Instead, they have to approximate how a galaxy behaves as a whole without actually simulating all of its individual parts and properties. And once the simulation arrived at present day, the result was strikingly similar to what we observe in the universe. And by constantly tweaking these approximations, increasingly realistic results can be achieved, never quite reaching true realism, but hopefully realistic enough. This is all well and good for all scientific endeavors, things like astrophysics, particle physics, meteorology, fluid mechanics, medicine, evolutionary biology, and the list goes on and on. But what about creating a simulation for entertainment purposes? So far, I've only talked about simulations as self-contained systems. You write some code, press execute, and hope for the best. But wouldn't it be far more interesting to create simulations that we can not only interact with, but also experience to the point of complete immersion? Software like video games are great examples of interactive simulations, and hardware like the Oculus Rift and the HTC Vive are some of the most immersive technologies available to the public. Well, they will be soon at least. Of course, these are only aimed at stimulating the audio-visual senses. What about everything else, like touch, for example? Well, there's full-body suits like the Tesla suit, vests like the Core FX, and gloves like the Hands Omni. These will give the illusion of actually holding virtual objects, getting hit by bullets, and possibly even give the sensation of temperature. Then there's also entire systems built to create a virtual experience, usually designed according to a specific game or game type. There's driving and racing simulators, flight simulators, railway simulators, etc. If you want to navigate inside a virtual environment, your best option at the moment is something like the Virtuix Omni. All of these technologies are fantastic, but they are not ideal. They are only the beginning of the virtual reality revolution that likely waits ahead. They are the monochromatic TVs before color, because the limitations of these devices stems from their implementation. You're always going to be aware that you're wearing a head-mounted display or that you're strapped into a locomotion platform. What's eventually going to replace these mediating technologies to create a truly immersive experience are BCIs, brain-computer interfaces. Research on BCIs began in the 1970s, and since then the technology has come a long way. So far, the focus has mostly been on repairing cognitive and sensory motor functions. As an example, neuroprosthetics are prosthetic limbs that can be controlled by a person's brain. People who's lost an arm and hand can now get a robotic prosthesis that they can control using sensors implanted in their brain. BCIs can also be used to allow paraplegics to walk again and help people with many types of paralysis. From an entertainment perspective, you can truly see its potential when combined with virtual reality. The Emotive Epoch is a publicly available BCI that you can actually use to play games with your mind. I mean, it's not perfect, it's actually far from perfect, but come on, you just cannot complain when someone has quite literally invented mind control. And better yet, in 2014, the first brain-to-brain communication was achieved between two people via the internet. In other words, telepathy is now becoming a reality. But we're still missing a crucial aspect. That is CBI technology, a computer-brain interface. And this is a significantly more difficult obstacle to overcome. In a typical brain-to-computer interface, a device receives information from the brain and tries to interpret what that information means. The worst that could happen is that the computer gets it wrong. In a computer-to-brain interface, the brain receives information from a device, and the worst that could happen is that you actually damage the brain of the user. In 2002, a blind man had a device implanted onto the visual cortex of his brain, which was in turn connected to a camera. This allowed him to partially regain his vision. The camera sent its signals to the visual cortex of his brain, and his brain interpreted these signals as if they actually came from his eyes. Another example of a CBI was used on monkeys. A monkey would control a virtual arm to touch one of several visually identical objects. When the virtual arm touched one of the objects, a signal would be sent back to the brain of the monkey to stimulate the sensation of touch, describing the fine texture of an object that didn't actually exist. But there's definitely a greater risk at play here, and it's gonna take a while until we perfect such technology. But once we've unlocked the mysteries of the brain, the possibilities will be virtually endless. If this technology continues to advance and is able to entirely escape the realm of science fiction, the world as we know it and the future we often imagine will dramatically change. When we try to imagine the distant future, we often think of humanity as these grand explorers of the universe. It's often just assumed that we will continue to expand outwards far beyond the Earth and the solar system. Of course, this is under the optimistic assumption that no apocalyptic events takes place and that we steadily continue to progress and innovate. Almost every non-apocalyptic futuristic science fiction tale describes humanity as a species that will expand outwards. And maybe that's true. But when this technology turns into reality, why would you want to? A powerful virtual reality could allow us to do anything and everything. No fear of harm or death, no irreversible consequences for your actions, no physical limitations. The ability to customize and manipulate the world around us to fit our personal needs and preferences. Just like in a dream, maybe it's possible to manipulate the brain's sense of time. Real-world minutes could turn into virtual years. Could that be why the universe can seem so lifeless, even though it's been around for such a long time? Perhaps every civilization that reaches a certain technological maturity realizes that expanding outwards to explore the universe is pointless when expanding inwards using technology allows you to do so much more. I've never made a video like this before, a video heavy on speculation and even touching on some philosophical questions. Hopefully you don't think I've gone completely insane. It's so difficult to make a video about these topics without sounding like you have some sort of religious faith in the Matrix waiting for Morpheus to come down from the heavens. It's far-fetched, highly speculative, and mostly just fun to think about.